Alright, so this is the introduction to hyperbolas, 10.4. The definition of a hyperbola is a type of conic section where all points x and y in a plane for which the absolute value of a difference or the distances of two fixed points are called foci. That sounds really confusing, but basically if you break it down, it's a type of form of a conic section which follows this type of graph and this type of equation. Here lies the first equation that we use for them, and here lies the second equation that we use for them. Here's the equations we use for asymptotes, which we'll get into in a little bit. This equation follows a graph in which the foci lie on the x-axis, and here it follows a graph in which the foci lie on the y-axis. If you look over here, we can see what a graph looks like broken down in components, much like the equations over here. HK is the center value as shown here, which would fall in here and here. The A value is the point between the distance between the center and the foci as found here, which would go there. And the C value is the distance between the center and the foci, which we can use to find the B value here. And that is all for the introduction for hyperbolas.
Okay, so in example number 1, we're going to be finding the standard equation of a hyperbola. So first, we have this problem, and it gives us the vertices, which are 0 and plus or minus 2, and the foci, which are 0 and plus or minus 4. And so from this, you can tell that the center is going to be at 0, 0, also known as the origin. So now we're going to draw this bad boy up real quick. So we're going to plot the vertices at 0 and plus or minus 2, and the foci at 0 and plus or minus 4. And we also have the center. So then this parabola is going to look something like this. Hyperbola is going to look something like that. And so then we're going to find the A value by looking at the distance from the center to the vertices, which in this case is 2, so you have A equals 2. And then you're going to find the C value, which is the distance from the foci to the center, which in this case is 4. So you have C equals 4. And so we're going to want to try to find the B value to get it in the standard equation. So for these problems, we're going to use the formula C squared equals A squared plus B squared. And so we're going to plug that in. So it's going to be 4 squared equals 2 squared plus B squared, or 16 equals 4 plus B squared. Then you're going to subtract 4 from both sides. It's going to be 12 equals B squared, and so B squared equals 12. And then because the center's at the origin, you can pour in the formula of y squared over a squared minus x squared over b squared equals 1. And you do y squared first because the transversal axis is vertical in this case. So the final equation is going to be y squared over 4 minus x squared over 12 equals 1.
So, alright, so we will now be drawing the hyperbola using its asymptote. We'll start off with the equation in standard form. A is equal to 2 and B is equal to 4. The transverse axis is vertical, and the effective center of the hyperbola is at 0, 0. Now, using the A and B values, they represent where the sides of the triangle will go. Since A is on the y side, the value will be 0, 2, and 0, negative 2. And then in the same logic, since B is on the x side, the other side of the rectangle will be 4, 0, and negative 4, 0. Then you use these points to complete the rectangle. And it doesn't have to be perfect. Then after that, you have to draw lines from the opposite corner pairs. So, and then you repeat it for the other pair as well. Now that you have the rectangle and the asymptotes, you can draw the hyperbola. Since it's a vertical transverse axis, it will be on the top and bottom of the rectangle. It will touch the midpoints of the rectangle and curve near the asymptotes. Add on the arrows and do it for the bottom as well, of course. And that's how you draw the hyperbola using asymptotes.
Alright, so to continue with our lesson, we're going to be talking about finding asymptotes of hyperbolas. So first we're going to start with this equation here, 4x squared minus 3y squared plus 8x plus 16. So we're going to use the complete the square method. So first you group the two terms. You take the grouping of the two terms, factor out the common here. Make sure that you factor here, move the 4 over as seen here. Then we're going to factor this inside term. You're left with negative 12 over here. Divide both sides by negative 12 to get this. And then move the negative, get rid of it, and you end up with this down here. Now from here we can transfer this to the graph over here because we have the center and the vertexes. So we put the center and the vertexes. Then we use the A and the B to find out the rest of the square. So we figure out the rest of the square here. Now the rest is the asymptotes because we need the asymptotes to figure out where the graph ends up, how wide it is, basically is what we're looking for here. So we know that these are the equations for the asymptotes here, and you use the Pythagorean theorem of the A and the B, or the A and the B and the C value as well. To find the terms needed, you take the A, you plug it in, the B, you plug it in, and then you just are left with x minus h, which we all know h is based off the given equation. So you take those, plug the terms in here, and you get this value, this first equation. And since it's a direct reflection to the second, we simply put a negative sign in front of it, and boom, you have both equations for both asymptotes.
Okay, so in this example we're going to be using the asymptotes to find the standard equation of the hyperbola. So first, this example gives us the vertices 3, -5, and 3, 1, and the asymptotes with formulas y equals 2x minus 8 and y equals -2x plus 4. Okay, so then by the midpoint formula, you know that the center is going to be 3, -2, and this parabola, or this hyperbola, has a vertical transverse axis with a value equals 3 because the distance from the center to the vertices is 3, so you know you have the a value equals 3. And so then you can use these equations right here for the asymptotes to determine the b values. So, and you use the slopes in here. And so with the first one, we're going to use m1 to represent the slope of this first equation. And so m1 equals 2, which is equivalent to a over b. And for this one, we're going to use slope 2, which is -2, which equals -a over b. And so using this, you can conclude that 2 equals a over b, which is 2 equals 3 over b. And then you conclude that b equals 3/2. So then our b value is 3/2. So now you're just going to plug this into the standard form of the equation for the hyperbola. And since we have a vertical axis, we're going to do the y's first. So y plus 2 squared over 3 squared minus x minus 3 squared over 3/2 squared equals 1. And that is your final equation.